Hi, I am Ben Solomon. I am going to make a presentation today, November 4th, 2021, about global warming and carbon dioxide. Okay, so the objective of this presentation is to explain why global warming is due to deforestation and not due to CO2 emissions, carbon dioxide emissions. And I do it in a manner where you can check everything that's stated here. I provide the references for the data and also explain how the IPCC, Intergovernmental Panel on Climate Change, arrived at their current decisions. Okay, let's look at some background. Metering stations are important to understanding what's happening in the world. And altogether, if you take a look at the Berkeley Earth Survey temperature study, there are 39,000 unique stations in the study, and with a combined of 1.6 billion temperature reports. So that's a lot of data. Okay, let's go to the next section. Global warming is real. The issue is not whether global warming is real or not. The issue is what's causing it. Okay, when you look at global warming, there's one thing you need to know. It's temperature anomaly. It's the departure from a reference voltage. That means the whole world temperatures are put together and the average is found, and that is the global temperature mean. And the anomaly refers to the difference between that reference point and some value that's been determined. For example, when the term is used, global temperature anomaly, it refers to the whole world. When the term temperature anomaly is used, it represents a region, let's say, for example, Europe. Yes, if you look at this graph, you can see that on the x-axis, you have CO2 emissions in kilotons, millions of kilotons. And on the right-hand side, right axis, you have global land and ocean temperature anomalies. And they are between minus 0.4 and 1. And over the following years, 1960 to about 2018. And you can see when you look at it, these blue dots are CO2 emissions, and the orange dots are the temperature anomalies. When you look at it, you'll say, yeah, of course they are correlated. But there's a big but. The climate claimers, let's call them climate claimers, say that when the temperature anomaly goes beyond 1.5 degrees centigrade, which is about 1.5 to 2 degrees Fahrenheit, not 1.5, but 2 degrees Fahrenheit, there will be a climate disaster. Europe, if you look at Europe, Europe has already exceeded at 1.5 temperature anomaly. The rest of the world combined, it's somewhere around 0.8 centigrade. So you see that even though the rest of the world has not reached 1.5 degrees centigrade, the European temperature anomaly is now at just over 2 degrees. But there has not been a climate disaster. So that tells us that, hey, something else needs to be investigated. Something else is going on. CO2 emissions is due to human activity. That is something we all agree to. And the graph, the world population, if you look at the graph, the world population down here on the x-axis, the CO2 emissions in kilotons, millions of kilotons, you can see there's a very good fit correlation coefficient is 97% between CO2 emissions and world population. And then the next slide, CO2 emissions, the cause of this global warming as measured by the temperature anomaly. See, when you look at this graph, this on the y-axis, you have the global temperature, and the x-axis, you have the CO2 emissions. And when you plot the data, you have a curve, not a straight line, a curve, which is in the increasing direction. But notice here, when the CO2 emissions was low, relatively speaking, the anomaly was a little higher than when the CO2 emissions increased. So actually the temperature anomalies actually dropped, and then it began to follow the narrative that the climate claimers have been proposing. And then in the recent history, 2015, I put the years here, around 2015, the global temperature anomalies did not change. Between 2011 and 2018, did not change, even though CO2 emissions went from 31 million kilotons to about 34 million kilotons. So that is another issue that needs to be addressed. Let's look at some background. Atmospheric CO2, I call it atmospheric CO2. This is the composition. If you pick up any textbook about the atmosphere or any basic physics textbook, this is the composition of the air, primary composition of the air. Nitrogen, oxygen, argon, carbon dioxide, and there are a few other rare gases. They are so rare, when you round it up to 2 decimal places, it doesn't show. It shows up as 100%. And so you can, using the molecular weight of the gases, and the density of the gas, pure gas, you can calculate the partial density. So for example, pure nitrogen will have a density of 1.165 kilograms per meter cube, whereas in air, the partial density of nitrogen is 0.755 kilograms per meter cube. And you can convert that into milligrams per meter cube and then into ppm. So 338 is, for carbon dioxide, is about the number we expect. The composition of that gas in the total atmosphere, in the lower 80% of the atmosphere, which is the lower portion of the atmosphere that accounts for 80% of the mass of the atmosphere, carbon dioxide is 10 to the power 12 kilotons. The total mass of the atmosphere is about 4 times 10 to the power 15 kilotons. So that's a huge, massive amount in terms of mass. Now, CO2, when you talk about CO2 emissions, we have to talk about it in comparison with something else. And so we look at this. This graph, the model, so I converted the data into very good models, so we can use the models to give much smoother lines. The errors are very, very small. When I don't show the raw data, the errors are very, very small. The model is fine. So you have a model of the CO2 emissions, and you have the model of the global atmospheric CO2 as measured by Mauna Loa in Hawaii. That's the oldest metering station in the world. And you can see that, again, you can see that the two are moving in the same direction. But notice that this gradient here is much steeper than this gradient. The second, and so when we look at this, This is by the lead scientist, a quotation by the lead scientist of NOAA, National Oceanic Atmospheric Administration. And he says the rate of CO2 increases has also been at a record high. And this is caused by fossil fuel burning. So there is solid evidence that human activities causes CO2 to increase, which I'm not disagreeing with. And therefore the association is that CO2 emissions are the cause of global warming. But then if you look at the CO2, the magnitude, CO2 emissions are on the order of 10 to the power 6, whereas atmospheric CO2 is on the order of 10 to the power 9, which is 3 orders of magnitude difference. That tells us something very important. It may not be carbon emissions that's causing global warming. Here, and I explain this a little bit more, the atmospheric, in 2008, atmospheric CO2 was 408.72. The emissions, if you convert the emissions into kilotons, like I explained a little bit earlier, it only converts into 4.64 ppm, only 4.64 ppm. That means emissions, carbon dioxide emissions is only about 1% of atmospheric CO2. And then here we see it again. This is the model. This is CO2 emissions as measured, measured. And this orange dots are the model CO2 by population, and the blue dots and the gray dots are the measured CO2 in the atmosphere. So you can see that the population model is spot on with the atmospheric model, and there is a big discrepancy in the quantity between the atmospheric and the emissions. Emissions is in millions, the atmospheric is in trillions. So climate change control policies with respect to CO2 emissions cannot roll back atmospheric ppms, because the max you can do, even if you achieved it overnight, let's say in the next 5 years, you brought carbon dioxide emissions to 0, let's say in 5 years, 2026, it will not alter this. It will drop from 408 to 403. We dropped it. We removed all this carbon emissions. So the story here is that there aren't enough carbon emissions, existing carbon emissions for climate change control policies with respect to CO2 emissions alter global warming. So we need an alternative carbon dioxide thesis. So let's look at population growth versus deforestation. So here the orange, here at the bottom is the population growth, Earth's world population. And on the x-axis we have the forest area in square kilometers. This is all taken from the World Bank. And this is in millions of square kilometers. It's gone from just under 40 million square kilometers. It's gone from just over 40.6 square millimeters to just under 40 million square kilometers. And so you can see that as the population increases, you can see that the forest coverage decreases because of deforestation. And the relationship is 99.9%, 99%, which is an incredibly good fit. You could practically say it's perfect. So we know population growth does cause deforestation. Now, is forest an indirect proxy to human activity? When you look at the forest, it is, but if you look at it in terms of CO2 emissions, you can see that as the forest coverage, a forest area drops, as the forest area drops, this is 1989 here, going to 2015, as the forest area drops, the CO2 emissions drop, and then they start picking up. So something different happened between 1989 and 1993. Probably there were recessions in that period. I know in 1990 there was a recession, and I believe 91 or 1990 to 1991 was a recessionary period, and that took the economy a little while to come back. And then after 93, as the forest area decreases, because you're going back this way, the emissions, carbon emission goes up. But you notice this spot here, that even though the carbon emissions has gone up to 34, the forest area has dropped a little bit. Okay, so that suggests that there is probably a different reason for for global warming. It is forest area is an indirect proxy for carbon emissions and therefore human activity. And that's why you get a nonlinear function of this. So when we plot the forest area and the non-emissions CO2 on the y-axis, so the forest area explains non-emission CO2. Non-emission CO2 is basically the atmospheric CO2 minus the emission CO2. We see that there is a perfect line between the forest area and the non-emission CO2, and it has a correlation, a regression coefficient of 99.98, which is even higher than the previous correlation we talked about. So we know this is proof that the forest is the main driver of atmospheric CO2. So, but then if you look at some of the leading scientists, climate scientists comments, they say, but plants capture only a fraction of the annual CO2 emissions. The previous graph I'd shown you, this graph basically says that that statement, this is the basic assumption behind all climate change models. That assumption is false. So if we calculate the forestation, how much forest do we need to get back to 300 ppm? 1960 was 317, 2015 was 401. With the corresponding forest areas of 42 and 40 million square kilometers. The target is 300 ppm. We need a forest area of 44.3 million square kilometers. And that means an increase of 4.7 million square kilometers of forest, which is about 11% of 1960 forest. So 4.7 million forests, to give you a visual understanding of what 4.7 million square kilometers of forest is. It's the US is about double that, 9.1. That's land area of the US. So 4.7 million square kilometers is just a tad bit over half the size of the US, and it's about 3.8% of the size of the world. So that is the kind of reforestation we require to get our ppm's level back to 300. Other problems: rising sea levels. You know, I've been going to the beach for most of my life. Many of them are the same beaches. And I came to this conclusion. I might be wrong, but this is my conclusion. You will know that the sea levels are not rising if you have visited the same beach again and again, year on year, or you have worked at the port year on year for decades. You will know that sea levels are not rising. In this picture, we see this World War II. I believe it's a World War II bunker. It's buried in the sand. It's buried in the sand not because the sea levels are rising. It's because it's sinking into the sand. So why do climate scientists say otherwise? I have no clue. This is something for them to answer. So let's go back and see. Climate scientists claim that sea levels are going to rise by 1 to 2 meters. That's approximately 3 to 6 feet. And so I did some calculations based on current sea levels, an increase of 1 meter, an increase of 2 meters, increase of 3 and 6 feet. That's a radius formed by the Earth. That's the average radius because the Earth is slightly flat. So the outer equatorial radius is a little bit larger than the polar radius. So if you take that average as a good estimate of what the full volume would be, to keep some calculations simple, because we are interested in the direction we have to go and not spot on numbers down to the 10th decimal place. So that's a volume of that sphere, and the change in the sphere between 0 and 1 meter is that much, to the power of 14 meter cubes. And if it's 2 meters sea level increase, the sea level, that sphere is about 10 to the power of 15. So that you can convert this volume of the additional increase in sea level water into ice, because ice shrinks, so it's 90% of the volume of water. You can get converted and you get this ice volume, and you plug it in here, and you say that the land area, this is confirmed that total land area of all the countries, excluding Antarctica, is 148.9 million square kilometers. And you convert that ice spread over that land area, and you see a 1 meter increase in sea level will require 3 feet of ice to cover the entire world. A 2 meter increase in sea levels will require 6 meters, that's 19 feet of ice to cover every country on this planet. So my conclusion is that ice doesn't exist. So sea levels cannot rise based on the ice that's on the land surface. Because water has to come from somewhere. If the water is rising, sea level water is rising, where is it coming from? Could it be Antarctic ice? Okay, there are a lot of issues we're discussing Antarctica. So ice, we must remember, because ice is 90% the density of water, when ice melts, you can get a cup of liquid and you put an ice block in the water, mark the level, and watch what happens when the ice is melted. You find that the water level is still the same. Ice over oceans cannot raise sea levels. So yes, when we calculate the Arctic melting, there will be some rise in sea levels. This is 8 meters is like 25 feet. It's not the 200 feet that the climate scientists say. 9 meters, 10 meters is like 30 feet, 30, 31 feet. It's not the 200 feet that climate famous. If you look at the winter maximum, it is around 200 feet water rise, but the winter maximum is this, and most of this ice is over oceans. So this cannot happen because this ice is over oceans. What can happen is the ice over the land can raise the sea levels by 8 to 9 meters. That's a possibility. Okay, but as the Australian Antarctic program says, ice sheet, understanding ice sheet is the largest unknown to future sea levels with respect to global warming. And I'll illustrate why they say that. That's my opinion of why they say that. This is the climate data from the stock station. The stock stations here is the coldest place on the planet. This is a photograph, a satellite photograph of Antarctica. And you can see when you look at all these ranges, you can see that if all this ice is going to be melted away, the temperature must rise by at least 14 degrees, at least, or 25 degrees Fahrenheit. That's not going to happen. When you look at how these temperature ranges happen, that's not going to happen. Summary. In summary, emission-based climate change control policies cannot reverse global warming, only reforestation. And there are news reports which says that there was flash floods here, there was flooding there, and all those sort of things. That's not due to climate change. That's due to deforestation. Deforestation. When you do not have enough trees in the soil, there's nothing to hold the running water in the soil, and it collects very quickly in the gullies and the channels and becomes flash floods. Do not confuse the two. So what do I have to conclude? The IPCC climate scientists fooled all of us, including me. I always thought that emissions caused global warming. No, this is very straightforward statistical analysis. If you have done statistics 101, you can reproduce what I've just said. So I conclude by saying that global warming is not due to CO2 emissions. It is due to deforestation. Deforestation accounts for 99% carbon dioxide in the atmosphere. Thank you. And if you like this, you can always reach out to me and we can discuss this.